So let's give a round of applause. Erika has spoken before, and objectives by the C, so another OBTS OG.
I've been to all of them.
And been to all of them, and so we're super stoked that we appreciate her flexibility giving us a talk. So let's give Erika a round of applause.
Oh, wow, first try. All right. So like Patrick said, obviously I'm not Phil Stokes. Hi, Phil, if you're watching from Thailand. I was last minute here so hopefully we're running a little bit late, so I'm not going to take up too much of your time. Hopefully go through this a little bit quickly, a little bit lighter maybe than some of the talks that we've been seeing. But basically I wanted to talk about binary emulation for threat analysis and hunting with a program that our company has created called Binee. So first of all, Binee was written by my coworkers Kyle and John, who presented this back last year at DEF CON. The video and slides and everything are available online, so you can see those if you want to watch the video. This was the PE focused, so Windows PE focused emulation. On our GitHub page, this is fully open source. It is available, and there are links to the abstract and the talk information on our GitHub page. So basically, just a short thing about me, if you haven't met me, I'm going to work with, for VMware Carbon Black in our threat analysis unit with Scott Knight, who presented yesterday, doing malware analysis and reverse engineering mostly, very recently focusing on more Mac-OS endpoint security. We're in the EDR world, so there's been more focus lately on trying to get better detection and prevention for Mac systems, because they historically, if you're in that world, have been kind of pushed to the side because Windows was a big focus. But as Thomas, who presented yesterday, published recently, this was the first year, 2019 was actually the first year where Mac threats actually surpassed Windows. So it's becoming a little bit more prioritized, thankfully, so people are more willing to put more effort into it. I have a lot of years in the security industry. I'm not going to go into that because I don't want to age myself. But I was also pointed out that I didn't have any cat pictures. So this is one of the few pictures where Hawkeye is not beating up Ozzy. They're actually looking like they like each other, which is not true. But we also have 4 chickens, which are not pictured. But you can find me on Twitter at GutterTroll. And if anybody actually knows the reference that that's from, I'll be impressed and buy you a drink. So why are we here? What is the point of all this? Why do we need binary emulation, especially for Mac? So the problem is with static analysis, you've got static analysis and you've got dynamic analysis, right? With static analysis, it's very fast. There's high coverage. But if we've got any sort of obfuscation, for like a regular program, it's not such a big deal. But when you are talking about, oh, my drink got taken away. If you're talking about malware, malware is going to do what it can to do obfuscation, anti-analysis, any of these things. So you're going to have probably you're not going to be able to run strings or something like that. You're not going to get any data out of it. So we might be able to run static analysis tools, but we may get nothing out of it from an IOC perspective. On the other hand, you've got dynamic analysis. You can spin up a VM, you can run the software, you can get a lot of IOCs out of there. You can, have a PCAP, you can see what network, what it's doing on the network, what it's downloading, things like that. But that's very costly time-wise and resource-wise, because every time you have to spin up a VM or something like that, that's going to take a lot of time and resources. So how do we kind of marry these two together and get the best of both worlds? Obviously, you're not going to have a 100% perfect solution to this. But if we can get a little bit more out of the static side and a little bit more out of the dynamic side without having to use all of the time and resources, we can at least, if we can get a partial solution, we can at least get maybe, what URLs is this thing reaching out to? What files is this dropping? Can we get a copy of this file? Is there a set of strings that this is deobfuscating? Can we get a list of those? That maybe we can at least automate this, push off these IOC and this data so that we can have it in the future and hopefully ingest large numbers of these samples and be able to process this in an automated fashion without having to have so much manual, so much manual work put on the analyst, because we all have limited resources. So we want to be able to do this at scale. So how are we going to do this? So Kyle and John, when they did this, they decided they were going to use Unicorn for emulation, if you're familiar. It's a very popular emulation engine, and also Capstone, which we're actually not using anymore, but ironically, the initial version of Binee was using a fork of Capstone called Gapstone, and we were actually using the fork that was developed by Scott Knight, who spoke yesterday, who was not even our employee at the time, but we found this out later, so it was kind of funny. But we ended up going back to, they reverted that and got rid of the dependency on Capstone altogether with native Go libraries. So why did they even start this project in the first place? Because there's lots of existing PE emulators. And here are just a few of them. Well, the problem is that there were things that, from the PE side, there were things that were missing, right? So there was none of these solutions provided an ability to configure system parameters like registry, if the malware is looking for certain files on the system, or registry things to be pre-existing. None of these were populated, or none of these solutions provided that. But that's from the PE side, right? So what functionality actually exists right now for Mach-O? Well, Unicorn supports the architectures. So it supports x86 and 64. And there is actually a couple existing things for Mach-O files. I don't know how to pronounce this, but the Keelang or Cheelang project is implemented in Python. I believe it's actually written by the Unicorn developers themselves. But the Mach-O functionality, even though it is there, is pretty limited at this point. But just recently, probably a few months ago, Confiant, and the link will be here in the slides when they're released, they demonstrated construction of, and dumping of stack strings. So they had a sample of malware that was actually, if you're familiar with stack strings, basically instead of having a string that's just an ASCII string in the binary, instead they push one character at a time onto the stack and construct them later in code. So basically this malware was taking, it had an embedded Python script that would run, but it was in the program as stack strings. So it was building it literally one character at a time. So Confiant wrote this very nice blog post up where they first went through with LDB and debugging to pull out this functionality and dump out the Python script. But then they also decided to take Unicorn and say, well, can we emulate this? Because instead of if you're going to use LLDB, you're on a Mac system, you're kind of constrained a little bit. If you're using emulation, you can actually do this from any system. It's platform independent. You can run it from a Docker container that you can spin up. So it gives you a lot more flexibility, right? And that the picture there is from their blog, one of the examples of their Python script. So what are we adding or extending from the work that already exists? The idea is that we wanted to be able to load up a Mach-O file with its dependencies, any sort of resources that are required, and be able to emulate it in a platform-independent way. So if you are running malware, you don't want to necessarily run the risk if you've got maybe a junior analyst or something like that, or an automated system. You don't want to be running Mac malware on a Mac system necessarily. And even with VM, VM escapes are, not really a thing anymore. But you just don't want to take that risk necessarily, and you want the flexibility of being able to emulate this from any system. So we want to be able to load up this malware and actually run it without and mock the system that the environment that it's in, that it expects, without having to actually physically spin up a VM and physically run through the loader for this, right? So we want a nice framework that will actually define the functions and API hooks that makes it easy enough that somebody can go in and say, maybe there's this custom function that this malware needs or is using. We want to make it easy for the analyst to go into the code and say, I need to add this extra API hook, or I want to mock up this system because this system needs this special configuration. The environment for this malware, it's expecting this OS version, these files to be in place, this configuration, these resources to be available to it. So we want an easy way to be able to instrument that. And so the best way to do this that we found was to make basically a configuration file where you can define pretty much anything that you want to. And I'll show in a second kind of a deviation just to give you an example of this, actually how we did it on the Windows side. So these configuration files basically give you the ability to make this mock environment very quickly on the fly. So you can basically just put anything you want to in this configuration file and create a mock environment for this malware that you can rapidly change. And actually you could even script it to say, this is, this file is looking for this. I'm going to modify this configuration file and reload it and rerun this. So here's an example. This is an example from the Windows side, but you can tell it, basically this OS Win 1032 gives you the API set for all of the libraries that the system or the malware is expecting. Code page identifier, you've got registry keys, and you can literally cut and paste these from the registry. So this is, on the Windows side, this is just an example of the kind of environment that you can set up. So why do we actually need this? I know from we have a pretty robust automated system, but we don't really have a lot of automated analysis and hunting capability on the Mac side. We have some automated detonation, but if you've done any malware analysis on the Mac side, a lot of that is their packages, their DMGs that have to be mounted. You have to run through an installer. You might have to authenticate. It's a little bit more difficult than the Windows side typically to automate this kind of thing, and it's very time intensive. If you're spinning up a VM for every single sample, you're not going to process millions of samples a day. And so without that dynamic ability, we don't have a very good, easy way of collecting actionable intelligence from these samples without having an analyst on the keyboard at the VM to actually physically do this. And also, because we can't process all of these samples constantly, we have a heavy reliance on external systems such as VirusTotal for collection, analysis, hunting, and things like that. So if we have a Mach-O capability to be able to do this statically, we can ingest a lot more samples, gain at least partial dynamic IOCs from these things from a much larger set of Mac malware. And that gives us a database of things that we can come back to later. And again, it may not be 100% coverage. Not every malware sample is going to run through emulation from start to finish. But if you get it to run at least as far as, let's say, the first network call, at least you've got, what did it load up? Maybe it dropped some files. Maybe it reached out to the network. You've got the URL that it reached out to, the name of the file. You can still get a lot out of this. Again, it's not a 100% solution, but you're still getting actionable intelligence and building your own database for this stuff. So what was the goal? Again, all we wanted to do was parse, load, and emulate a Mach-O. Just the minimum viable product here. 64-bit Mach-O binary, standard libraries. Let's just see if what can we get out of this with the minimal effort, because we have very limited resources, of course. And so we already had this robust release of Binee for the PE side of things for Windows. So let's say we said, let's develop the same architecture for Mac, a working skeleton framework that can be very easily extended. And if an analyst wants to add some hooks in, we have an easy framework there in place that anybody can go in. They can pull this down and add what they needed to and be able to customize it very easily. And the eventual goal was to release this Binee for 64-bit Mach-O initially. And the public release on our GitHub would be similar basic functionality as to what we have for the Windows release that's out there already on our GitHub page. So the idea was, we've got this existing framework, right? So there are all these functions and helper functionality that's already built in there. We'll just take, this is written in Go, and there's this great debug library that has all of this built-in functionality for parsing Mach-O files. This is great, we get it for free, right? So it's gonna be super easy. And just take the existing code that's for PE files. We're gonna just basically match that, do our unicorn emulation. It's gonna be, smooth sailing, right? Just gonna emulate the same thing that we did with Binee for PE files. And again, this unicorn emulation has already proven, like I said before. We've got the Python implementation that's there, and the Confiant blog that showed, this is pretty straightforward, right? So yeah, what are the results? Hey, it builds, right? So it runs, it builds, we're good, right? Yeah, no. So it turned out to not exactly be as easy and straightforward as I thought it was gonna be. So basically, backstep. All right, we need to start over here. So basically, obviously, there's no full-time resources. Unfortunately, we had a dedicated thing, and if anybody lives in the malware analysis and EDR world, emergencies happen, right? So things got pulled off. So, but the biggest, we do have functionality, and the skeleton code is partially functional. It does run, builds, but all the full emulation is not there yet. But the biggest lesson for me was that, I write code, I reverse code a lot. Writing an actual program, a fully functional program, is very different. And I haven't been a full-time developer. I'm not going to give the years, but let's just say it was back in iOS 4. So it's been a while. So the fact that some of the things that we were expecting to get for free from the intrinsic Go libraries, we did not have. So made the development, incremental development, a little bit difficult. So basically the status is we still have a lot of work to do, but the skeleton functionality is there. Definitely hoping to release this publicly soon, and we'll definitely announce that when that happens. But we do still have a lot of work to go. We're running on time here, so basically I just want to say, once, from a threat hunting perspective, once we have this kind of like partially dynamic data, there are a lot of uses for this, right? Again, it's not a 100% solution, but you can, if you've got hackers or things like that, you can actually, if you can get at least get the malware to partially run, you can get a lot of dynamic data that you wouldn't have access to generally for a fraction of the cost of actually having to run these things fully. So you can use this for Obviously hunting, if you've got IOCs like URLs or file names or things like that. Yara, sample fingerprinting, those kind of things. So you can imagine the possibilities. So future, obviously we want to complete the, functionality, increase fidelity. We're going to do the public release. My coworker is actually currently working on a single step mode for the PE side that will obviously be ported. We want to add ELF file and extend Mach-OS support, and then add some more anti-emulation and anti-debugging and typical malware mitigations. But yeah, I'll wrap that up because we're on time here. And this is our GitHub repository. It's under Carbon Black Binee. We have a Slack workspace, and hit me up on Twitter if you have any questions. And yeah, thanks.